this question. Let's show you how I would approach this question, because the way you set this up will help you to actually answer the question. So the graph shows the pH changes when calcium hydroxide, so I need to remember here, calcium hydroxide, this is an alkali, and that means it contains hydroxide ions, is added to hydrochloric acid, so this is an acid, as the name tells us, and that means it contains H plus ions. Explain the shape by explaining which ions are present in the solution at the three stages and why these ions are present. So let's have a look at what we've got in the table. So this scale here is measuring our pH, and you can see, again, let's add some notes to this. So here, this region here is where it is an acid, and this region here is where the pH is an alkali. Now remember, 7 is very special because 7 is pH for neutral solutions. Carry on at the axis, and along the bottom here, this is showing you the mass of calcium hydroxide that's been added. So this is adding the alkali to the acid. So first of all, stage one. What's happening at stage one? Stage one, you can see here that the pH is in the acid region. It's very low pH. It's about 1, so pH 1, so this means it's an acid. And why is it an acid? Because there are lots of H plus ions present. So that's all I'm going to say here. So stage one, so it says for each stage, describe the pH changes and what causes this change. And you can see here, in terms of changing, that the pH stays fairly steady even though we're adding the calcium hydroxide, the alkali, to it. So let's put that into words. So the pH remains fairly constant. It increases slowly. There are H plus ions present in excess. So there's more H plus ions, which is why it is a acid. Okay. Now remember, every time we add calcium hydroxide, we're adding OH minus. OH minus, OH minus is being added. And then we get to this point here where the pH changes very quickly and it whizzes up here. It's pH 3 and it's jumping all the way up here to as high as pH 12 by the time it gets to the top. Now this is passing this very, you can see here, remember this point here, this very important point here, which is where it is neutral. And we need to make that clear in our answer. So stage 2, the solution is neutral. And why is it neutral? Because the H plus ions react with the OH minus ions to make water, and water is a neutral substance. So at this point, these H plus ions and OH minus ions are the same concentration, and therefore it's completely neutralized the solution. If we move on and carry on with here, to go this way, we're still adding more OH minus ions, and that's why it then becomes a very high pH number, because here you can see we're heading up into the alkali region, so we've got excess of OH minus ions. So here we can put that into words as well. The pH increases as it contains an excess of OH minus ions, and that's explaining the stage number 3.